All right, so last video we looked at how to do one-step mole conversions, and so what we're going to look at now are how to do two-step mole conversions using our mole island. So we're still going to start the problem off by finding what we're starting with and what we're ending with. So let's do that first. I am on page, let me double check my pages before I tell you to go to the wrong place. I am on page 6 of the Unit 7 book, and I apologize if you can hear my dog barking. He's just particularly excited. So I am on page 6 of your Unit 7 book, and I'm working on problem number 1 of the section that says mixed mole conversions. Problem says how many oxygen molecules are in 3.36 liters of oxygen gas at STP. So I underline what I'm given, 3.36 liters of oxygen gas. Here's my starting point. And I'm going to convert to oxygen molecules. Okay, so those are my two different units that I want, liters and molecules. So if I look at mole island, I'm focusing on this half of mole island. So I am here at liter island, and I want to get to things. So the way that I'm going to do that, I'm going to have two steps now. I have to go from liters to moles, and then I have to go from moles to things. I cannot directly go from liters to things. So my two conversion factors that I'm looking at are 1 mole equals 22.4 liters, and 1 mole is equal to 6.02 times 10 to the 23rd molecules using Avogadro's number. Okay, so when I start off my problem, 3.36 liters, and I write the formula for oxygen gas as O2 using our Brinkelhoff and what we learned in Unit 6. Because my units are liters, I want them to cancel, so I'm going to move them to the denominator, liters of O2. And so here's where I'm going to make my first unit conversion. I'm going to go from liters to moles in a one-step problem. But as we've already discussed, moles and molecules are not the same thing. So moles goes to the bottom of our fraction, and molecules is going to go on top. And so now I fill in my conversion factors. This might be where you feel a little overwhelmed, but we've taken it step by step, so we're going to continue on. Here's my first piece. 1 mole equals 22.4 liters. That's this fraction. 1 mole equals 22.4 liters. So all we have to do is fill in our fraction so it's a true statement. 1 mole, 22.4 liters. Okay, the next fraction here is where I'm going to use the next part of mole island. 1 mole equals 6.02 times 10 to the 23rd molecules. So this time the 1 is going on the bottom and Avogadro's number is on top. So what you need to do when you type this into your calculator, we are going to divide by 22.4, then we have to multiply by 6.02 times 10 to the 23rd. So when I do that, my final answer is going to be 9.03 times 10 to the 22 molecules of O2. And that is with the correct number of sig figs. So if you didn't get that answer correct, please make sure that you divided by 22.4 and then multiplied by 6.02 times 10 to the 23rd. Let's look at number 2. Find the mass in grams of 2 times 10 to the 23rd molecules of F2. Here's my starting place. And I'm going to end with grams. So if I look at mole island, oops, run out of room. Okay, it gave me molecules. I want grams, so I'm not going to use liter island. So I know 1 mole is equal to Avogadro's number, and 1 mole is equal to the molar mass. So you'll quickly see that mole island will be something that's embedded in your brain after we use it so many times. So I start off my problem, 2.00 times 10 to the 23rd molecules of F2. I don't want molecules, so I put that in the bottom in the denominator to get it to cancel. And I'm going to convert to moles in one step. So that's using this half of mole island. This is our step number 1. Now, I don't want moles of F2, so it goes to the bottom, and I convert up to grams of F2. So my first fraction, 1 mole, 6.02 times 10 to the 23rd. Again, I'm just writing in my conversion factor, so it's a true statement. And then here, I have to use the periodic table. Remember, going from gram island to mole island is the only time that you actually have to do a little bit of work. So 1 mole is going to be equal to, I have that the molar mass of F2 is 38. Oops, sorry. Flip the slide on you. So I do not know what's happening here, you guys. Sorry about this. So 38 grams per mole. Remember, I have 2 fluorine atoms. So I'm going to divide by Avogadro's number. Then I'm going to multiply. And so my correct answer with sig figs is going to be 12.6 grams of F2. All right, let's try one more all together. Determine the volume in liters occupied by 14 grams of nitrogen gas at STP. So I underline where I'm starting. Okay, I'm going to convert to liters at the end. And so I can see that on my mole island this time, these are the sections I'm looking at. So I need 1 mole equals 22.4. I need 1 mole equals the molar mass. Okay, so 14 grams. And now I have to remember nitrogen gas, the chemical formula is N2. That came from what we learned in Unit 5 and Unit 6 using our diatomic atoms. So 14 grams of N2, up to moles of N2. Then I'm going to go from moles of N2 to liters of N2. All right, when I fill in my conversion factor, I'm going to have 1 mole over 28.02 grams of N2. Then I'll have 22.4 liters over 1. I'm going to divide and multiply. Oops, sorry. And that gives me 11 liters of N2 as my final answer. So if your work looks like mine, but you're not getting the correct answer, please be careful using your calculators. Type things in 2 or 3 times if you need to make sure you have the right answer. So remember, you have to show all of your work, and your answer has to have the correct number of sig figs and units in order for it to be fully correct. Take your time, read very carefully. I want you to go ahead and finish number 4 and finish number 5 of this page before we move on. So go ahead and pause the video. All right, the answer to number 4 is going to be 4.65 grams of N2. And the correct answer to number 5 is going to be 3.69 times 10 to the 21 particles. So in that number 5, they gave you 2 values, but it very clearly says that it has a molar mass of 233 grams. So that's just telling you your conversion factor, okay? If you need extra practice with moles, which you do, you're going to look at pages 8 and 9 and then 10 through 12. These are excellent practice problems. 10 through 12 especially has them all randomly mixed up. Sometimes they're 1 step, sometimes they're 2 steps. There are even some problems that require you to use the metric system. So real quickly, let me remind you of what I mean by the metric system. So our mole island uses grams and liters, but you might also see milliliters or kilograms or milligrams, okay? If that's the instance, you have to go from kilograms to grams using the metric system and then use mole island like we have been, okay? So if you don't remember your metric system, King Henry died by drinking chocolate milk. We always put the 1 with the bigger unit and fill in zeros. So there are, in 1 kilogram, there's 1,000 grams. All right. In 1 liter, there are 1,000 milliliters. If you need more help with the metric system is covered in Unit 1. So please go right on back, look at Unit 1, and review the metric system. Okay? Thank you for watching. You have to practice this in order to get better, and if you need any extra help, find your chemistry teacher.